Okay, hello everyone. Thank you for joining us today. I'm Liz Mancini. I'm the Director of Member Services here at AAPA. Welcome to today's webinar, The Future of Sustainable Port Technology, presented by Vahle. Vahle is a leading global manufacturer of electrification and automation products, including mobile and data communication, absolute positioning, and control systems. Backed by a legacy of innovation and over 100 years of experience, their products are implemented around the world where safety, quality, and reliability are top priorities. They serve a diverse range of industries, including intralogistics, automotive, amusement, crane electrification, and port technology. I just want to let you know we'll be collecting your questions throughout the webinar, and please address them into the chat or the Q&A, or wait until the end, and then we will add a time that you could ask them live if you would like. And with that, it's my pleasure to welcome Marc Zulgani, Marketing Manager at Vahle, to introduce today's presenters, Marc Detweiler and Simon Schulz. Marc, the floor is yours.
All right, thank you so much, Liz. So good morning, everyone, and welcome to the PowerDock webinar. I'm Marc Zulgani, and I will be the moderator today. We're excited to share how PowerDock is transforming the way port vehicles are charged with safe, efficient, bottom-up technology. Our agenda today starts with a company overview from Marc Detweiler, followed by Simon Schulz, who will dive into the technical aspect of PowerDock. We will then move to our FAQ session to address your questions before wrapping up. This session is being recorded, and you can submit questions at any time using the Q&A panel. So I'm pleased to introduce our speaker today. First, we have Marc Detweiler, Global Head of Marketing and Product Management at Vahle. Marc has been with the company for over 11 years, starting in R&D as electrical engineer, and later leading the global product management and marketing. He holds a master's degree in power system engineering, and then play a key role in driving innovation and positioning Vahle at the forefront of automation electrification. Joining him is Simon Schulz, product manager at Vahle, with over a decade of experience in product and project management. Simon specializes in smart technology and innovation, and holds both a master in smart product and solution and a bachelor degree in business and management. Together, they will walk us through today's session, starting with the company overview from Marc, followed by Simon, that will deep dive into the technical aspect of the PowerDock. Marc, it's all yours, sir.
So first of all, do you see my screen?
Yes, we can.
Yes, perfect. So then also from my side, thank you, Marc, for your warm words and introduction. And hello and welcome also from my side to this webinar. And today I will give you a brief but hopefully electrifying overview of the Vahle Group, a company that has been driving innovation in automation and electrification for over a century. So let's start with how it all began. So the story of Vahle begins in 1912 when Paul Vahle regularly faced a challenge. So let's take a short journey in time. Imagine you're in 1912, mobile crane trolleys frequently shut down there during the crane operation due to poor or bad quality of isolation of the cables used at that time. So these cables then often became damaged, leading to short circuits and ergo to production stops. And Paul's solution was revolutionary. He invented the world's first copper conductor rail with sliding contact systems, allowing then the cranes to draw power reliably, robust, and safe along the whole crane aisle. And this innovation not only solved a major industrial challenge, but also laid the foundation of Vahle's company, making the beginning of a legacy in electrified mobility over 100 years ago. So let's fast forward to 2025. Vahle is now a global leader in electrifying and automate applications, which are in motion. So basically for you guys, wherever an application is in motion and requires energy, data, positioning, or controllers, Vahle is present. And with that in mind, you could see here already in the video a few examples or proof of our global footprint, like the Ferris wheel eye in Dubai, where we equipped it with isolated conductor rails, people mover in Venice with conductor rails, large or small cranes around the world with enclosed and open conductor bars, HGVs with battery charging contacts, automated storage and retrieval system with compact conductors, or ensuring safe and reliable operation within the port areas with energy, with communication and positioning. And with that in mind, let's take a look of the overview where we are. And we are active where the world creates movement with cranes, like process cranes, gantry cranes, heavy duty cranes, or much more. We're active where the world generates mobility in automotive with EMS lines, with forklifts, with the HGVs, or with skid lines, which you see here on that slide. We're active where the world transports items in intralogistics, for example, sorters, shuttle system, and ASRS, also automated storage and retrieval systems. And we are active where the world trades goods at ports with applications like ERTGs, like STS cranes, like RNGs or straddle carriers. And with that in mind here, again, let's zoom out and have a bigger look at Vahle at a glance. We've done 200 million in 2024. We have more than 800 people worldwide working for us. We have 14 market organizations across the globe, which are clustered in 4 regions, the Americas region, the European region, the EMEA region, and the Asian Pacific region. We have 5 product groups serving this, the energy transmission. We call it, by the way, the power, the data communication system. We call it the COM. Positioning systems, we call it the POS. Control system like the drive, and system solutions where we then combine the products together like a Trimotion arm for the ERTG application, for the ERTG arm, where we need the power products, the COM products, and the POS products. And last but not least, the markets I showed you already. But next to that, we also have opportunistic markets like amusement rides, applications like dart rides, Ferris wheels, or free fall towers, or people mover applications there, cable liners, elevators, trams, or the clean room market where we serve with OHT as an overhead hoist transportation application. So let's return to our focus topic and bridge the content to the reason why we are all here today. On this slide, you can already see a wide range of applications, Vahle solution in port technology. We are support the applications shown in the middle to the left side, including again conductor rails, festoon system, positioning system, data communication system, and so on. And on the application on the right side, mostly terminal trucks, this is the focus of today's webinar. So this is the key initiative for sustainable port operations in the future, and we're excited to share more about it today. So that's the point. So gentlemen and women, that was that quick journey through Vahle's legacy, markets, and applications. Hope you enjoyed that a little. Thank you for your attention, and now let's dive deeper into our solution with the PowerDock. Handing over to Simon.
Thank you very much, Marc, for the introduction, and thank you for giving us a global picture about the company. Now we dive deeper into the topic, and we show you how Vahle is reshaping port electrification through innovation. And for that, at first we are looking at this slide, how in the past the port vehicles involved during the time. So on the very left side, you can see that we have a traditional port truck, but this doesn't count only for port trucks, should show in general port or terminal vehicles. We had in the past, or still manual driving plus manual, in this case, diesel refueling. Then when OEMs started to build terminal trucks or other port vehicles with large batteries inside, we are having a manual driving plus a manual charging. And the next step would be then where we want to focus on at first, where we go this step from manual driving and manual charging to manual driving and autonomous charging. Plus, there is the option where we are having autonomous driving already, like a HEV or a full automatic autonomous terminal truck, that we have the combination between this vehicle and the manual charging, and we want to go this step further to have an autonomous driving plus the autonomous charging. So on the next slide, you see why we want to go this step, because the manual charging can cause some problems. The problem is that when charging gets missed after a shift change, the vehicle isn't charged and is not ready to operate for the next shift. So very often responsibilities about charging is not clear. Then with the manual charging, we don't have a chance to make a so-called opportunity charging. So in small idle periods or breaks, it is not possible to get out the vehicle, put the CCS2 gun inside of the car quickly, and then get in the truck. So we want to have a solution ready for a opportunity charging. Then this case, or in this case, the CCS1 or CCS2 charging, the manual one is not ready for automation, and for sure the operational inefficiencies with the manual charging, that is, it disrupts workflows and increase the labor demands. And yeah, on the next slide, I'm going to show you the system architecture of the system we are working on. So from the very left, you can see on number one, the DC charger, like any normal existing DC power charger. On the number two, we have this tower where we have all our control unit inside. On three, we have a base unit where we will push a table up to charge a terminal truck or any other vehicle on the terminal through a conductive or through 5 conductive contacts. On 4, you see wheel alignment guides. So for the test phase, we need to use them just to be more precise on these pins. Then on number 5, there is a mobile unit. I will show you later then more detailed pictures like this receiver plate, which needs to be implemented on a terminal vehicle to pick up the power from the mobile unit. The grayed out things, you see, it's clearly not our system, like the charger itself or the terminal truck, or not delivered by us, like just the system which is in full color, like 2, 3, 4, and 5. And on the next slide, I'm going to show you why we have chosen the charging option from the bottom. As we know, there are more systems on the market, also in not only in terminal operation, but also in public transportation, where, for example, buses and so on are charged from the top. But for our system, we have seen that the bottom is just we have a universal compatibility, as more or less they are like the same opportunities from the bottom as a terminal truck, a heavy forklift, an HEV, or a reach stacker are just having like the same technical or more or less the same technical circumstances from the bottom. Also, because the design is very space efficient. I will talk then later on a slide about it, that with this design from the bottom, it should be possible in the future not only to have the charger on a specific parking lot, but also inside of a container aisle, for example. So also an argument for the charging from the bottom, that we have the advantage that we can park the vehicle and just go over it again and like implement it into the daily process, and not just like have to start in a parking lot and go back to do any like operation at the port. Then let's go to the next slide. There is like a more detailed picture in the middle of the base unit. So the initial idea was to create something which can be used then for terminal trucks, heavy forklifts, HEVs, or reach stackers, all in one system. And with this solution, with the PowerDock, this should be possible. But as you have seen now renderings only, I'm going to show you a video from our latest prototype. Please let me know if you can see the video now. Yeah, it should work fine. I'm gonna stop here just to explain this one. The thing the guys are rolling inside our lab should simulate the truck. So they put the receiver unit on this wagon to drive over the base unit, and then you can see that both the base unit and the receiver unit are having covers that open, and after that you can see that these massive pins are getting pushed up to the receiver plate from the bottom, and after successful connection with the CCS2 protocol, we can transfer up to 300 kilowatt in peaks, 350 kilowatt power. And as you could see, the guys, wait, I will just go back a little bit, they also shaked the vehicle. So the system is very massive, but still we have like very high tolerances, so it's really built for a heavy duty use here. Then let me go to the next page, because we very often get this question, because the question, why did we use a conductive solution instead of an inductive solution here? And the arguments are clear. Just to specify this one, we are not against inductive as Vahle itself. We're in the inductive business for decades, more in the intralogistics. So we know about conductive, but for this special use case, the conductive definitely wins, as we have like a much more compact size for the same power transfer as an inductive one. So for an inductive system, the setup would be much bulkier than with the conductive ones. Then also the conductive ones, we have the opportunity here to handle misalignments without any efficiency loss. The problem with inductive is so that when you don't have the receiver plate exactly over a base unit, you have a massive efficiency loss. And this we can handle with the conductive, as we'll show you then on the next slide. We made these receiver plates with a certain size, so the parking doesn't have to be that precise. For sure, on the conductive side also, the system is more compact and lightweight, especially the mobile unit, which could make problems on some vehicles if the mobile unit on the vehicle gets too massive and too heavy. Then on the conductive side, for sure, we don't have such a high electromagnetic interference as on the inductive side. Very good point also on a more economic side. conductive is always cheaper than an inductive solution, and less complex to integrate in a system. For sure, we have to integrate it into a terminal truck. With the conductive side, this is much easier. With an inductive, this would be too complex. So for this use case, the conductive technology with a higher power and an easier handling definitely fits better for this application. Then let me come to the next slide, where I'm going to show you. I'm going to show you that the system really works reliable even in harsh environments. As I already said before, the parking tolerances are really 4 and minus plus and minus 4 inches side to side, plus and minus 6 inches front to back, as the receiver plate you've just seen in the video is really massive. So the pin doesn't have to be exactly in the middle, as we know that with this heavy duty vehicles, it is impossible to exactly park in one position. Also, we have angular tolerances, plus minus 2 degrees side to side, and also plus minus 2 degrees front to back. And from top angle offset, we also have 2 degrees. So again, here we know that with this kind of vehicles, it can happen that just the surface isn't exactly straight, or if they are just like loaded heavier on one side than the other. So the system is built like this to really be able to handle these tolerances. Also, like in the offset in 2 dimensions. No, actually in 3 dimensions, plus in every dimension in the angle. Then again, engineered for extreme environments, so the system can really handle everything which is important in the port. So salt, extreme heat, minus 5 degrees Fahrenheit plus up to 130 degrees Fahrenheit is not a problem for this solution. Also, as we have a receiver unit mounted on the truck, on the bottom of the truck, for sure, with unloading and loading these trucks, there are a lot of shocks and vibrations. We thought, and our engineers, we thought about everything that the system can handle these shocks and vibrations. Then on the next slide, some specifications about the system. The table maximum height is 10 inches. The minimum height is, so when the table is lowered, 5 inches. Again, you can see like these big covers, which will cover all the pins, and will open then when the vehicle is over it. Again, here the performance specs on the bottom, 300 kilowatt DC charging power, maximum current 300 ampere. We tested even for a short time peak 350 ampere with 1000 volt. On the next slide, I'm going to show you that we for sure thought about all safety aspects here for the system. So as I already explained, both the receiver unit and the base unit, like we installed covers for both of them. So these covers are protecting the pins and the receiver unit from everything. So from salt water, from water, from mud, and ensures a reliable contact when the pins are going up to the receiver unit. Then the verified connection protocol. So even if the receiver, even if the base unit is open and somebody would like touch them, nothing would happen. Actually, in the CCS 1 and 2 protocol, it is specified that at first there have to be a successful connection between the pins and the receiver unit. After the successful connection, there is a data transmitted over one of the pins. And after we have the successful data handshake, then the vehicle says to the DC charger that it should switch on the power. So before that, there is no power on the pins, just to clear that. Then the secure vehicle lockout on the bottom, which means that when the base unit is in up position, it is not possible the vehicle makes any movement, just to protect the vehicle and the charging pins for any damage. So the system will communicate with the car that everything will stay safe. But even if like something happens, for sure the safety sensors will detect everything, and if there is any water in the system or anything else will happen, the system will always go in a safe shutdown and then will close the cover. So on the next slide, I'm going to show you why we felt so comfortable making this innovation, as the conductive power transmission, as Marc already explained, is our core business for over 110 years. Also proven in ports worldwide with powering ERTGs. One second. With reliable and durable systems, as Marc already explained, and the strong US footprint. We've been in Houston for over 50 years and trusted across multiple industries, especially in charging large HEVs. With the systems you can see in the middle, on the bottom in the middle picture, we already did charging for large HEVs for VFT, is an automatization company for BMW, also with together with Bear Automation for Audi, and DS Automotive for John Deere. And as you can see, companies of these big coil HEVs are also trusting us with our charging contact. But still, even if we have this long history and this confidence in like this, we also know that the conditions in the port are completely different, as everything is harsh, windy, wet. There are just like harsher conditions than, for example, in an automotive factory. And for this, we are making this pilot in a port in Mexico by the end of this year, just to test the next prototype under real port conditions. And during the operation, which we are making with an OEM terminal truck, we for sure get real-time data, and then we can even more improve the system to have then operational scale production. So as I said, we tested it multiple times in our German lab. Everything is functioning now this year, by the end of this year, the next step in the port. Yeah, this pilot will help us validate the concept, but for the ultimate version, we have a bigger vision than in these parking lots. You can see right there. The idea is then in future to have a seamless integration inside of the container aisles. So as we said, the original idea was to have opportunity charging of trucks or other vehicles within the terminal, makes it just more ideal to integrate it into the daily process. So this is the main idea. It's just gives us so much more or so many opportunities in futures. As you can see on these 5 bullet points here, for example, that we have an optimized space usage, so these charging zones are not needed anymore. It is automation ready, so even like the HEVs, they don't have to go to a certain charging point. The idea is to really charge them in short sequences during unloading, uploading, or small waiting periods. Yeah, with this vision in mind, let's now turn to the questions you shared during the meeting. I haven't seen the chat yet, but Marc now will moderate the discussion, and the other Marc and me, we will provide then hopefully a good answer to these questions.
Right. Guys, if I can just jump in, we've got 5 questions from the audience. Payal asked, it would be great to hear how your implementation goes in September. How are you guys going to announce that?
Shall I?
Absolutely.
Go on, Simon.
It would be great.
Absolutely. Absolutely. I mean, at first, for sure, we will handle it internally. So our whole development team, our engineers are involved just to track really all the data during charging, all the possible mistakes which can happen. And after we had a successful proof of concept, we won't hide this information. For sure, we will let anybody know who is maybe interested in the system, or to try a second test pilot, as there is actually one more prototype available, right, Marc?
Yes, that is absolutely correct, that we have still one additional prototype in Germany there, where we want to equip, hopefully also soon. Also here, there's also some other topics where we have in Europe, trying to have a pilot also with a nameless brand of an OEM, but this is also on a very local facility where we move on with the test. So it's not a port, it's a closed facility, but trying to have there also real application knowledge close to the German headquarters.
Okay. Great. Next question. Joe asks, where do you manufacture your systems?
I think I can. Do you want to answer it, Marc?
No, move on, Simon.
No, I mean, the system is currently built in Germany, but our engineers actually made all the components so that as a construction, I don't want to say it's like a simple construction, but still it's like a lot of massive steel, and the steel components can actually be produced worldwide, which means that we can be compliant for any kind of tariffs or so on to produce it also locally. So we had this from beginning on in mind to produce it locally in Germany, but also if we have the need to produce it somewhere else, we can easily produce it somewhere else, as the system is, to be honest, not a high-tech solution. We wanted to keep it somehow in some components very low-tech.
Okay, great. Okay, Paul asks, what is your sense of the challenges your port customers will face in getting enough electrical infrastructure ready for your chargers?
So can you repeat this question, Liz?
Of course. What is your sense of the challenges your port customers will face in getting enough electrical infrastructure ready for your chargers?
Well, I mean, what we have seen so far from our existing customers, there are these parking lots very often already with the DC chargers. So I think that in general, there is this direction this whole market is going. So the infrastructure is needed anyway, like with manual charging or with our system. We are just like adapting like an additional advantage to the existing chargers. I don't know if I could answer the question correctly.
Okay, we have one of our attendees has asked, for the PowerDock, do you retrofit to existing yard trucks? And how does the receiving unit connect to the battery system?
I think this is an ideal question for Marc Detweiler.
I can also jump in to that question. So yes, retrofitting is possible with the Isuzu. We already thought about that. So for sure, we need to have the mechanical infrastructure. We need to adapt it to the bottom surface of the existing fleet. And for sure, then we need to connect then the DC plus, DC minus, as well as the communication pins, the free ones, to the existing one. But since this is a CCS2 protocol, it is more than possible to adapt it very seamlessly on the mobile side to existing fleets. And also there, if you have then the existing charges there, again, that Simon showed you that already on this overview picture. You just need to have the existing gun of the existing DC charger, plug it into our solution, have the mobile plate available to your retrofitted fleet, and it will work. So that's the beauty of the system, what we thought about from the very first beginning, to make it as simple as possible for the port application.
Also, what I want to add here, also from the beginning, our initial thought was to go on both retrofit and OEM. So absolutely made for retrofit. Yes.
Yeah, thank you, Simon, for that additional comment.
Great. Luis asks, what happens if the humanless system fails? Can the truck still be charged?
Yes. When the system would fail for any reason, imagine any failure. Imagine one water sensor detects that there is, I don't know, there is like 2 inches of water float. The system is floated in 2 inches of water, and one of the water sensors detected. You could still just unplug the current charger of our system and put it in the truck manually. So when we would retrofit a truck and fix the receiver plate on the bottom, the existing CCS2 socket will still work. So this is just like an additional function. So we don't remove the existing CCS2 socket or CCS1 socket.
All right. David asks, when will you roll out BABA compliant equipment?
I mean, as I said, we thought already that we are able to make everything BABA compliant. As we are having this proof of concept by the end of the year, I can really not say in detail when we have like a finished BABA compliant product ready to sell on the market. I don't know if we should give any forecast to this one. Question to my colleague Marc Detweiler.
Again, as soon as possible for this, because again, the drawings and so on from the existing pilot are made to be able to produce it locally. For sure, then a few components like the battery charging component, which is our IP, they need to be shipped from Germany. That is for sure. But all the other steelworks, or for example motors, which are from the shelf or where you can buy from the shelf, this is then possible for in that particular question for the American market to purchase and manufacture it. For example, in use in our market organization.
So we do have some FAQ that we already have like 3 questions ready for you. So one question says like, is PowerDock compatible with various DC chargers?
So this question goes to me. Yes, it is compatible with various DC chargers, as there is this international standard CCS1 and CCS2. So the power or the company of the DC charger doesn't matter. It is compatible with our system. as it's more or less a plug-and-play solution. So you can really put the CCS2 charger in our system, and our system more or less reacts as an extension of the existing charger. And maybe I will add something to here, because we already got this question: what if a vehicle wants to use this charger which does not have the receiver plate yet? You can also unplug the CCS2 charger, this gun, out of our terminal and use it then in any other vehicle. So we are very flexible with this one then. So the third one: how quickly does charging start once the vehicle is parked? As I said, our initial idea was to make the system available for opportunity charging, which means that in a very short amount of time, the vehicle needs to be charged. So when the parking position is completed, now on our prototype, it takes around 40 seconds until the both covers are opened, the table is pushed up, and the pins are connected. So, but the 40 seconds is just like what we did now, as we wanted to have it like super safe for the first pilot. As you know, for sure the electric model can go faster, but we wanted to have it super safe. Additionally to this 40 seconds, there is the CCS2 protocol, or CCS1, where there is a data communication between the vehicle and the DC charger. And in this data communication, the vehicle communicates with the DC charger and asks about, okay, how fast can I charge, and so on. And after that, there is a ramp-up phase up to, let's say, again, 60 seconds, what we have discussed so far with truck OEMs and BMS system providers. So 40 seconds, where we still have a little bit of a buffer, plus this 60 seconds, and then the power is on the vehicle gets charged with full power.
Okay, and then I guess the next question is, what is the required maintenance frequency?
As a question number 4, I will take. So as of now, we recommend for sure a visual inspection every quarter. So we hope that when we have this pilot installed, that we have that more experience and can increase to a half year or to a complete year. Again, we want to be here also on the safe side. What I can tell you is the contacts itself, they are already in use since 2 or 3 years, also in an outdoor application. What I not can tell you right here, but it is proven already in outside conditions. And also what I would like to add here is that for sure the whole system will provide, or will have some sensors when there is something with the malfunction. Everything is then connected to our main unit, to our PLC, and we have the ability also to communicate via an LTE modem to the overall system, that we can share this information to the port authorities right away. Okay, there is something, there's a malfunction. Please send your maintenance team over there. And then, as Simon mentioned already, then in case this truck started to charge and the malfunction was happened and the tray table shut down, and then the staff can go straight to the gun and can then add this to the manual charging, that it can move on to charge, that the operation stoppage is as short as possible.
Thank you for the answer. Now, question number 5: how do you ensure reliable connection between the base and the mobile unit?
Okay, I will take this one. So as you have seen in the video, this table is getting pushed up with a very strong force against the vehicle from the bottom. And additionally to that, when the system is making this connection, we switch on to super strong electric magnets, which means that the receiver and instead, as you could see, our engineers shaking this whole prototype, that the system is really reliable, even if, for example, the truck is getting un or uploaded. So this was the main idea behind the system, so that it really should work also with some vibrations and shocks in or during the operation.
Okay. Thank you, Simon, for the answer. Liz, do we have any questions that we may answer on the Q&A?
Don't have anybody else, but I'm going to just do a last call. Anybody else have any questions for the team? You got a clear floor. Going once, going twice, going 3 times. Oh, no more questions.
Okay.
Do you guys want to do a final?
Yeah. So so if anyone has any questions, please, type your questions in the chat or Q&A. We definitely going to get back to you. I want to thank you all for joining us today and for taking the time to learn more about the PowerDock. We truly appreciate your engagement and the questions you have shared. As a reminder, today's session will be or has been recorded, and the recording will be available on our website. And then also we will send you by email so you can revisit any part of the presentation or share it with your colleague. I would like to, and if you have any more information about our PowerDock or solution, please visit our website. You can see it on screen, vahle.com/USA. You can also reach out to us for today's speakers directly for any questions. You can contact Marc, you can contact Simon. You guys have their email address over here. On behalf of Marc, Simon, and the entire Vahle team, we thank you again for being here, and we look forward to connect with you soon.
That's great. So that wraps up today's webinar. Huge thanks to Marc and Simon for sharing your expertise, and thanks to all of you for joining us today. And I hope you're leaving with ideas and insights that you can put to use at your own port. Have a great rest of your week.